Looks like people are still trickling in. I'll give you one more minute to find a seat real quick. Sweet. OK. My name's Andrew Liu. I work on the Azure Cosmos DB team. Today, we're going to go and show off a bunch of new stuff that we have with Cosmos DB. So let's get started. This is going to be a jam-packed session. We have lots of stuff that we're releasing with Ignite. I'll walk you through each one of these. I'll start with a demo on, just in case you guys are going, hey, wait, what is this thing again? No problem. I'll give you a quick demo of what Cosmos DB is. And then we're going to go through and speed through a bunch of different updates that we're releasing with the product. And then at the end of this, we're also going to have a special guest where we have one of our partners, Informatica, that's going to be on stage to demo some of the really cool integration that they're doing with Cosmos DB. And of course, I'm going to leave time at the end for a Q&A. And I know that this is going to be a very densely packed session. So if you don't get your question answered during the session, don't worry about that. I'm also going to just hang out around after the session's over. So do catch me if we run out of time at the end. OK, so first things first. What the heck is this thing again? What is Azure Cosmos DB? Cosmos DB is a distributed database. It is Microsoft's premier NoSQL database in the cloud. A lot of my colleagues, my peers, over the course of Ignite, you're going to see lots of presentations this slide presented. But in a nutshell, this is a distributed database where we have a backend that supports sharding, replication, resource governance that gets manifested in the turnkey global distribution, elastic scale of throughput and storage, being managed as a resource-governed cloud-native multi-tenant service with predictable low latency, consistency, as well as backed by a bunch of SLAs. This gets exposed in a number of different ways. The way I like to make this analogy is if you think about .NET or Java. In .NET, it doesn't matter if you're writing C# code or F# code. It runs on the same common backend. Likewise, in Java, you can write Groovy, Scala, Java. It doesn't matter. It compiles to the same bytecode that talks to the same virtual machine. With Cosmos DB, we're taking a very similar approach where we have a common underlying distributed database system. And we expose it through a variety of different APIs, including a Tables API, Cassandra API, our own core native SQL API, a Mongo API, and of course, a Gremlin API. So let's take a look at a demo. And I think this will help illustrate the point a lot better. So here I am in the Azure portal. Let me make sure that, OK, looks a little small. So I'm going to zoom in a bit for you. And in this demo, what I have is I've set up a Cosmos DB account. I've set up 2 different virtual machines set up in 2 different regions. One of these virtual machines is going to be based in West Europe. The other virtual machine is going to be based out of West US 2. The point of this demo is I'm going to go and set up a globally distributed NoSQL database that spans across multiple geographies. And I'm going to go and send traffic from an application that is hosted on 2 different VMs from 2 different regions to just show you what the power of global distribution, both in terms of scale as well as throughput, look like. Cool. So I'm going to go to my Azure Cosmos DB account. I'll show you the configuration I currently have. It's a globally replicated database. I'm currently in West US to West Europe, Australia East, and Japan West. And of course, I can always add additional regions. So for example, if I wanted to be in even more continents, I can always click and add a region and hit save. Now, if I go and look at the Data Explorer, this will kind of give you a more concrete visual on what the product actually looks like. In a nutshell, a database is all about storing data and getting data back really, really fast, right? But not all databases are created equal. And so some of the things that we're working on is, number one, from the partitioning and sharding capabilities, is we want to give you elastic scale. And so let's take a look at the elasticity of this. I'll show you our very first workload. What we're going to do is I'm going to start with 2,000 request units. 2,000 request units, just as a refresher, is the compute units for scaling up and down your Cosmos DB. And if I go over to this virtual machine that I have 2 different applications, one that I'm going to test latency, and the other I'm going to test throughput, basically the 2 dimensions of performance. So if I go over to this application I have over here, what you'll notice here is I'm going to spin up a bunch of tasks. Basically, this is how I'm going to go and spin up many, many threads. And within each of these different threads, what I'm going to do is, in a tight loop, write to the database. And what this will allow me to do is basically set up an app that's going to hammer the crap out of my database. That's the technical term for this. And we're going to just have many, many threads just trying to jam as much data into the database as possible. So what I'm going to do here is I'm going to start with 2,000 RUs. I've compiled a binary here. And what we're going to do is it's going to burst upwards because when t equals 0, when I divide the RU spent over time, the time window is very short and allows us to temporarily burst. But what you're going to see here is over time, it's going to settle around 2,000 RUs because that's what I've configured the database. One of the really, really hard challenges in elastically scaling a database up and down historically has been maintaining availability. So what discourages you if you're doing, let's say, like VM, like topologies, if you're going from, let's say, 2 shards to 3 shards back to 2 shards is, how do you actually do so without bringing your website offline for a maintenance period? Can we go and do that? Well, it turns out yes. So what I'm going to do is I'm going to show you an example of scaling. We're going to scale 10x by adding a whole nother 0 to the workload. We're going to go and hit save. And we're going to go back to this app. And what you're going to see is I'm going to spin up even more threads to just jam a lot of data into this database. It takes .NET for my little app, my VM here, a few seconds to warm up. But what you'll see here is as it warms up, it's going to go and just jam a lot more writes just like that. That's how scaling 10x looks like in Cosmos DB. Very, very simple. In addition to scaling throughput, what you also want to care about is latency, right? Throughput's all about how many concurrent requests per second I can just bombard the database with. So imagine this is Black Friday. You have a retail workload. You're running an e-commerce website. Lots and lots of shoppers are hammering your website. But not only do you want to handle a lot of shoppers, you also want to make sure that that page load time is very, very snappy. So let's go and take a look at the throughput side of things, or sorry, the latency side of things. If I go to my latency application, much more simple application. I'm going to just go in a tight loop, while true, go and run a query on the database, and take a look at the latency that I observe. So as you can see, it's very easy for me to achieve single-digit millisecond latencies on the query path. But here's where the kicker is. How do I solve the speed of light challenge? What if my workload is a global workload in which I have users connecting both from the US as well as I have shoppers coming in from Europe? If I run that exact same workload from my second virtual machine deployed in another region, West Europe, here's what I want to show the latency problem. The speed of light problem is if at the time of performing a request, you have to ship a packet halfway around the world, well, it takes some time to do that, right? We have a fiber optic cable. We're going to beam a photon from point A to point B. And unfortunately, I haven't really figured out how to send that photon faster than the speed of light. And honestly, if we could figure that out, maybe databases is like one of the low-hanging fruits to really solve, right? So how do we cheat this? Well, if we look at the playbook on how retailers have been doing this historically, imagine if you're shipping goods from one continent to another continent. It takes a while. But if you set up fulfillment centers all around the world, you can actually do same-day shipping everywhere around the world. That's cool. So what I'm doing is I'm cheating the speed of delivery by just bringing my goods really, really close to where the user is. So what if I could globally distribute my database, exact same data set, active-active topology, live replicating? I could go and query from the local region. So that's what I've done here is in my database, I've already set it up to be active-active across West US and West Europe. And intentionally, just to demonstrate the latency impact, I intentionally commented out connecting to West Europe. But basically, what you can do with these clients that we have is you can set up a preferred order list. So that way, if West Europe fails, and in this case, it might make sense to go and fall back to, let's say, East US and then West US too. And likewise, my West US app might prefer West US, then East US, and then West Europe. Of course, in a live environment, what you would do is you would take these are all enum string values, and you'll make it environment variable driven so that you'll have like preferred region 1, 2, and 3. But now that I'm configuring this to talk to the local region, West Europe, this is kind of cool. I can get really, really low latencies, like single digit or about 10 millisecond latencies, no matter if I'm in West Europe or in, sorry, this is West Europe again, or West US too. So that is really, really powerful. Basically, we found a way to cheat the speed of light, not by sending packets faster than that, but by doing live replication, and then at the time of query, talking to a local copy of that. Now, here's the kicker. If you've ever worked with databases before and you've set up database shards, database replicas, one of the hard things has historically always been, well, how do you do just basic application evolution on this, right? So over time, what you're doing is, hey, I have a sharded replicated database, and I need to do things like, application team wants to go deploy a new feature, alter tables, create index. How do I deploy a migration script, alter tables, create index across, let's say, a dozen shards across multiple replicas while maintaining availability of both the application and the database? Well, it used to be that this is just a really hard deployment problem, and the easiest way to solve this is have a maintenance window. But here's the kicker. What if your business tells you, no, you can never go offline? In fact, I want you to always stay online. So what we've done is we've made the database inherently flexible, such that we like to call it schema agnostic or schema free. Schema never goes away. If you don't know your schema, you don't know how to query your data. But what we can do is make the database very flexible in nature on that schema to support dynamic schemas. So an example here is I have a record here. I'm simulating an IoT workload where I just dumped some random JSON here I found for IoT telemetry. But let's say the business is going to go and add tagging to my devices here in the telemetry I'm sending. So an example is I'm going to add a tag property, and that's going to have an array. Let's say this is a blue device. And I now want to run queries to find all of my blue devices. So I'm going to go ahead and just add a property. Check that out. I didn't have to do alter tables or anything, no migration script. And then when I go and query this, where array contains c.tags blue, I also didn't have to do create index. We can do automatic indexing over dynamic structures to allow for the schema evolution so that from an application development perspective, you can go and move fast and iterate very, very fast. That, in a nutshell, is what Cosmos DB is all about, is we're making distributed databases really, really, really easy. Now, a lot of you guys, I'm guessing, have already used Cosmos DB, so let's get to the good part. What's new? Actually, let me get a feel for the room. How many of you guys are already using Cosmos DB? Awesome. And I assume then the inverse is who hasn't used Cosmos DB, of course. So let's talk about new stuff. And in that demo, we talked about elastic scale, low latency, and just how easy it is to develop applications. The very, very first thing I want to talk about is aggregation performance and group by. Now, if you've been using Cosmos DB for a while, which it looks like pretty much a very large chunk of this room has, you know that this is one of our top requested features. In fact, this is going to be one of the core themes is I really want to show that for our roadmap, we are very, very developer-centric and user-centric. We really listen to your feedback. And so if I go to our user voice page where we allow you to vote on feedback for the product, you'll know that out of the top 4 items, we've made a lot of progress. For example, we just implemented skip take a few months ago at build, and we're collecting your feedback. But group by as well as autoscale are 2 of your other top requested items. And I'd like to take this opportunity at Ignite to go and, well, make updates to this user voice page live in front of you guys. So what I'm going to go and go ahead and do is I'm going to go to a data set I already have here where I've loaded a bunch of different documents into a Cosmos DB container that I've set up the SQL API on. And you'll notice here in this data set, I've jammed a bunch of different entity types into the exact same container, which is, from a best practices standpoint, what we expect you to do. But now if I go and run a query, one of the features that was highly requested is a long time ago. One is from an aggregation perspective. It used to use a lot of RUs. And I want to show you now that from a latency perspective and from an RU perspective, this is super fast and snappy now. It just runs instantaneously. Basically, what we've done is we've made a lot of improvements on our indexing layer to drastically speed up aggregation. But we didn't just stop there. What we wanted to do is also give you a lot of the familiar things that you expect out of a database coming from a relational database when you move to a distributed database. Oh, well, we've noticed that you've optimized for basically elastic scale. How do we go and bring a lot of this flexible query back to the database? So one of the other things we've worked on is if I want to go and do group by queries, let's say I want to go and get a count of how many records by different types I have. So I do a select type count as documents, group by c.type. And can everyone see the font okay? I'm not sure if it's too big, too small. Oh, whoops, group by. Syntax correction. There we go. Just needed to add a by the by. Anyhow, what you'll see here is just like that, I can run group by queries. And so I'm going to take this opportunity to log into our user voice. Hold on. I'm going to sneak over to look at where I put my super secure password. Oh, that's OK. I'll update it after this, session. But basically what I'm going to do here is by the end of this session, you're going to see all of these graduated away from started over to need feedback. I do want your feedback. Please play around with these new capabilities and do send us your feedback. Now, in addition to aggregation performance and group by, you saw the other thing that people have really wanted is the ability to automatically scale request units within your Cosmos DB containers. Historically, one of the things that we've held very dear to our hearts is the elasticity of scaling your database up and down and giving you very, very fine-grained knobs, right? And historically in databases, that was hard to do. If you're doing node counts, if you're doing, like, let's say, CPU cores, how do you add, like, 0.1 CPU core? Well, you can't do that. And so what we would ask you to do is even if you wanted 0.1 more CPU cores, we'd ask you to buy, well, a whole nother CPU core. With Cosmos DB, we made that very, very fine-grained in the concept of request units. But we've also found that, hey, over time, we've introduced a new concept for you, and managing and dialing up and down these request units isn't always the easiest exercise, right? Writing automation for that. And so what we're doing here is we've released this capability called Autopilot Containers. And what you can do is you can choose a max throughput. Today we've started off with 4 different tiers. But over time, what we're going to do is we're going to just relax that, and you can set any value you want for the max number of RUs. And what we'll do is we'll set up the container such that it's going to automatically scale with your workload, looking at what are you consuming in terms of RUs, and dynamically provisioning that provisioning your RUs such that it matches your workload to help you save on costs. I'll show you how you're going to set that up. This is set up as a preview feature for now. And when you log into the Azure portal, let me go to one of my accounts. And what I have is I've set up multiple accounts before enabling the preview and after enabling the preview. So if I go to one of my accounts before enabling the preview, what you'll notice here is when I go to my Cosmos DB account, on the left-hand side, we've added a new navigation menu for enabling preview features. And here's how you can register an account for Autopilot. Once your account is registered for Autopilot, you can go over to the Data Explorer and then create new containers. And instead of manually inputting how many RUs you want for that container, and this works both at a database level as well as a container level. So right now, it was the database throughput. Now I'm looking at the container level throughput. But rather than setting up a manually provisioned container, I can go to the Autopilot and go and choose different max thresholds that my container is going to automatically scale up and down for. What's really cool about this is if you have, let's say, new workloads where you don't really know how many RUs you need, you can go and just let us take care of that for you on scaling that up and down with a max threshold, so that way we don't have billing overruns. But over time, if you do need a very, very predictable throughput, very, very predictable performance, let's say you're a massive retailer, it's Black Friday, you really want to know that you can, at any given moment, hit a number. You can also still go back to the manual provisioning and upgrade an Autopilot container over to manual provisioning to go pin the number of RUs and dedicate a set of RUs such that you can have the peace of mind that that container at any given point can serve that throughput. Sorry, let me go to here. So the next thing I wanted to show off is you saw, I'm guessing yesterday, a lot of announcements about Azure Synapse. Everyone knows about Azure Synapse, right? Yes? OK, good. So Azure Synapse is our next evolution of how we're thinking about data warehouses and doing computation over data lakes. And one of the common things we've noticed with Cosmos DB is a lot of people are using us as a hot, updatable data lake for doing things like telemetry stores. And so, well, we thought, you know what makes a lot of sense is if we can combine the capabilities of Azure Cosmos DB and Azure Synapse, well, you got a really, really powerful system where you can have a transactional workload writing lots and lots of telemetry into a hot, updatable data lake like Cosmos DB. And then you can run analytics using Azure Synapse to do all of the analytics over that telemetry. So the way we've built this is we want to make this as friction-free as possible. We do not want you to have to worry about doing things like lengthy ETL pipelines. And so within Cosmos DB, historically, we've had this transactional store, this row store that's a fully SSD-backed store. What we do live, if you enable the analytical store, is it's going to go and replicate that to a cold store. And what you'll find is the cost characteristics of the analytical store is a lot more optimized for doing, well, analytics, whereas a transactional store is geared for doing, well, your transactional workload. By splitting these two up, you get a few different advantages. One is workload isolation, the performance isolation. So if you want to do some batch processing, let's say you're going to run a Spark job on top of Cosmos DB, well, you can pin it to the analytical store, and that way it'll always make sure that it doesn't interfere with the transactional store. And this is going to be an active replication pipeline, so that analytical store is always going to be kept up to date. One of the other cool things we're doing with this is we've made this purpose-built for running Spark Analytics on Cosmos DB. When you're doing transactional queries against a database, typically what you're doing is you're doing what queries that look like seeks, right? Needle and haystack queries. Select star from this container where device ID equals ABC. Well, the row store does a very, very good job of that. But when you do analytics, what you're typically doing is you're doing aggregations like, hey, find me the average temperature or the P99 temperature of this particular column. And so what you'll find in the analytics world is if you lay this out into a column-oriented format, you can get much, much more efficient IOPS in terms of reading values out of a particular column. And so this way, if you want to go and support hybrid transactional analytical processing workloads, HTAP workloads, we give you a really, really great platform for doing so. So the way that we're working with Azure Synapse is Cosmos DB acts underneath the hood as a way of doing scale-out storage. And then Synapse does the scale-out compute. And what you're doing is you're running a Azure Synapse job on top of scaling out a compute job on top of your scale-out store. So we've exposed this in multiple different ways. The first experience that we're doing is Azure Cosmos DB has a built-in notebooks functionality, which can invoke into the Azure Synapse compute, which will then power and run analytics on top of the Cosmos DB analytical storage. So let's take a look at what that looks like. So here, if you go to the Azure, the Cosmos DB account that I had set up earlier, if you go to the Data Explorer, we have a set of built-in Python notebooks. And with those Python notebooks, we can do things like if you wanted to go and analyze a data set stored in Cosmos DB, we actually have a bunch of sample notebooks for you to run just right out of the box. What we can do is, in this case, we're going to import a data set. I've already actually created this container, and we have set up a JSON import file. where we'll go and read through it and import it into the database. But from here, what you can do is pretty cool things. You can run queries directly out from Cosmos DB, input that into a data frame. Here we'll see that we've created that data frame. And then we can do things like if we want to run some basic analytics, like a sum, we can run it directly from the data frame. We can use data science libraries like pandas and other things in the Python ecosystem for processing those data frames, as well as building visualizations so that if I wanted to go and prepare some data to go and build a graph and then plot this out onto a world map, this will take some seconds to load. We're using a library called Bokeh. That'll go and generate a data frame for us that's processed and generate a visualization on top of that. While this is loading, I'll also show you how to plug in your Azure Synapse job for doing analytics and scaling out on a Spark cluster. So here I have a second notebook that I've set up. In this notebook, what it's doing is I'm configuring both a connection string into my Cosmos DB account. I'm configuring it to use the analytical store, and I'm also setting some parameters for my Spark cluster running in Azure Synapse. Once I go and do that, I can run analytics by reading the same data frame or reading the same data set into a data frame and do some plotting around that. So in this case, the example data set I have is race car telemetry from a bunch of NASCAR cars going around a bend. And if I go and plot the lat-long coordinates of each of those different cars at each different point in time, I can actually look at not just remapping the shape of which they're driving when they're accelerating, when they're braking around a track. But this also allows you to then get some insights on it, like, hey, high-performing drivers, how are they behaving differently from low-performing drivers? And if you were, let's say, a race car driving team, you can use this to go and, well, really understand how do you go and take your driving to the next level. In addition to that, what we've done is we've announced and released a bunch of developer experience updates. One is for bulk execution. If you've been using Cosmos DB for a while, you noticed that we had a bulk executor library, and it was an independent NuGet package from the original SDK client. We've converged these two together, as well as this brings bulk execution to up to a point where we can run this on .NET Core. And to make this friction-free, if you're doing a bunch of operations against Cosmos DB, so example here is I'm loading a bunch of create items as an async task. As you go and schedule these against the client internally is going to go and batch these together by enabling allow bulk execution equals true. In addition to bulk execution, we're also doing transactional batch execution. Historically, if you want to do ACID transaction against Cosmos DB, what you would do is run a store procedure writing some JavaScript. We get it. Not everyone here is a JavaScript developer. And sometimes you want to see this in the programming languages that you are using for your actual application, whether that is .NET, Java, or something else. So what we're also doing is we enabled a new batch functionality within the SDK, where in a very fluent manner, you can go and schedule, let's say, a bunch of writes, reads, etc. And here I'm doing a create, a replace, an upstart, as well as a delete, and then batch these together so that they are atomically executed in a single batch against the database. We love DevOps in addition to just doing the development of our applications. From a DevOps perspective, what we've added is a bunch of PowerShell commandlets as well as some new AZ CLI capabilities, so that if you want to do things like from your CI/CD pipeline, be able to dial up, dial down RUs, or manage other configurations on your database. For example, do index policy updates, time to live, data retention policies. You're able to do so using both PowerShell if you're a PowerShell user, as well as through the AZ CLI. And what we've done is we've also extended this for all of our different APIs. Another thing we hold dear to our heart is security. And we make bets in many different areas of security, ranging from encryption, authentication, authorization, as well as network security. Within the network security space, one of the latest improvements that we're adding is integration with the new Azure private endpoints. If you haven't played with Azure private endpoints before, basically the short summary is if you're using our VNet, our Azure VNets, virtual networks, what you can do is isolate a workload away from the public internet and isolate it only within your virtual network. Now, this works really well when you're doing Azure to Azure service communication. One of the challenges historically has been how do you actually bring that virtual network to hybrid deployments if you're also doing access from your an on-premise application server, or if you're, let's say, logging in from a development laptop. And so what the private endpoint allows you to do is assign a private IP to all of your different Azure services and expose that to a private link so that everything on-premise can also access those set of Azure resources. Recently, we've just added Azure Private Endpoint integration with Cosmos DB so that way you can also lock down your Cosmos DB with a set of private IP addresses for access from, let's say, a local VPN connecting into the Azure VNet. We've also introduced more ways to save. We've had reserved capacity for a while, and we're over time lowering the barrier to entry. Now this starts at a very, very low, modest 5,000 RUs, as well as rather than having to pay upfront, you can do so with monthly billing. And of course, the last set of updates I have for Cosmos DB is we have in our Mongo API the brand new 3.6 support. This has a bunch of different API improvements in terms of what operations we support. And some of the heavy hitters are we've had aggregation pipeline in preview for a while. With all of the new aggregation improvements that I showed you earlier with our group by, we're able to GA that pipeline and make that run very, very fast over large data sets. And in addition to that, we're also bringing that up to parity with our native SQL API, in which we're exposing the change feed through MongoDB's concept of change streams. Now, those are a bunch of updates from Cosmos DB itself. We also really love our partner ecosystem. And I have a guest speaker here. Bill, you want to introduce yourself?
Hi, Andrew. I'm Bill Kriegbaum. I'm Senior Director of Product Management at Informatica. I'm responsible for cloud, big data, and analytics ecosystems. But I got to tell you, Andrew, I'm distracted. I've been sitting down there thinking the next time I'm in Redmond, I think we need to tackle faster than light photons.
Oh, yes, let's bring it on.
Absolutely. So we are moving quickly today, and I don't want to spend a lot of time marketing our product. Hopefully, many of you are already Informatica customers and users. But I do want to highlight that our dedication to the Microsoft partnership and our broad support for Microsoft Azure. And I'd like to announce right now, right here, we support Azure Synapse. It's the easiest product I've ever built. So very happy to do that. What we're going to focus on today, though, is to get the value out of Cosmos DB and building these globally distributed applications, you need data in there, right? And that data is going to come from many different sources, applications, legacy databases, whatnot. And with our cloud product, Informatica Intelligent Cloud Services, we're able to take data from pretty much any integration pattern and bring it into Cosmos DB. And the way we look at it, though, is that there's some table stakes capabilities. You need data, data integration, you need application integration. But on top of that, we really want to focus on some of those other patterns and the value-added services like data quality, master data management, cleansing, governance, so that you have that complete end-to-end application.
Yeah, so one of the things that we commonly see is as people modernize their applications, let's face it, everyone has been on relational databases for a while. But one of the challenges is if you want to modernize that with Cosmos DB, well, you got to rethink your data model. Bill, can we make this easier? Like rethinking my data model from a bunch of normalized tables and bringing it to Cosmos DB, how am I going to do that?
Well, you know what, Andrew, it turns out we actually have that demo prepared. And what we're going to do is we're actually going to take a look at bringing some data in from Teradata and load it into Cosmos DB. But what we're going to pre-join a number of tables, and then we're going to actually structure it in such a way that it really takes advantage of the hierarchical capabilities. So we got to take the show on the road, man. And yeah, so let's go ahead and jump into doing a demo. And if we pop over into Informatica Intelligent Cloud Services, I'm going to go into data integration. And one of the things I want to highlight, though, is that to get the best data into your application, you need to find the data first, right? And so we're going to actually take a moment and look at some of our integrated data catalog capabilities. And we're going to do some searching for some customer data. And we can see that our enterprise data catalog has come back, and it's looked at the entire data estate, right? And it's brought back a ton of information. But we already know that we want to pull data from Teradata. So we'll go ahead and trim that list. And we're going to dive right in here into the customer table. And so very quickly, we're presented with an overview of the customer table. But if we look at the columns, you'll see that we get some profiling information, we get some data domain information, and this is our Claire AI engine that's automatically going into that data source, looking at the information and applying business definitions to it so that I, as a business user, can go easily find information based on business terms, not on schema definitions. One of the most important things in understanding whether or not I want to use the source is where did this data come from originally? And with Informatica, you're able to see both the lineage of where all the data came from and also where is it going to, because that tells you, is this data actually being used? Is it, And then last but not least, let's go ahead and take a look at relationships, because we want to do some joining of tables. We'll drill into, look at some of the relationships, and we'll come back to this one in just a moment. So I'm satisfied, I like this table, let's go ahead and bring this in. And so I'll automatically provision that into an existing map that we've built. And so we now have this table ready to go. Now let's go get that other table, and then we'll be able to run this very quickly. So we'll go back to our data catalog, and I'm going to come over to fetch that dim customer table. We'll bring that into the map. And so now we have both of our sources ready to go. And you can see that by this map, it's very simple. We're going to do a quick join of the two tables, and we're going to do some cleansing. And we actually have introduced earlier this year our cloud data quality product. And this might be a great way to do, for example, some address standardization, clean up the addresses, making sure that we've got good zip codes to run future analytics with downstream. One thing I want to highlight, though, is if we look at the hierarchy builder, this allows us to take those two joined relational tables and actually bring that hierarchy to the party to really take the best advantage of Cosmos. So that is it in a nutshell. So I'm going to come back to your slides.
Awesome. So we have about 6 minutes left. I did want to open this up into a Q&A. I know that I've run through a large number of updates with Azure Cosmos DB, as well as spotlighting some of the cool new capabilities that we've recently released with the integration of Informatica with Cosmos DB. There are a set of microphones set up here if you want to come up and ask questions. And while we do that, I also wanted to get a gut feel for the room here. How many people here are excited for group by support? OK. How about Autoscale? Yes. OK. I now know we had a bet within the office on which one of these two would resonate more. Looks like Autoscale is a clear winner here. Let's start with this mic over here on questions.
My question is on the seventh one, private endpoint preview. So how does it make different from the service endpoint, which already exists?
How is private endpoints different from service endpoints in VNet? What service endpoints allows you to do is really Azure to Azure PaaS connectivity. Historically, what we would do is if we had multi-tenant PaaS services, there's two different ways of deploying that within a virtual network. One is VNet injection, in which if it's a service that deploys on VMs, an example is Spark. If you're deploying Spark on VMs through, let's say, Azure Databricks, that would use the VNet injection route, where Databricks itself didn't really have to understand the concept of a VNet. Only the VMs did. And as long as we deploy that job on those VMs, we're good. The other set of PaaS services has always been things like Cosmos DB, App Service, where they're really born in the cloud Azure services, where they don't actually run in public VMs. So for example, for Cosmos DB, we actually, to get the incredibly low latency and high throughput, we run on bare metal. Well, the way we bring that into a VNet is through Azure Service Endpoints. And that allows you to go in. We have a different way of doing authentication authorization within the virtual network. Basically, what we're doing is we're using a signature-based scheme, where within the VNet, we sign every packet that is flowing back and forth through services belonging to that VNet. And for VNet service endpoints, what we're doing is we're echoing every packet that comes into the service. We check for that signature. Does this packet actually come from the VNet? If so, accept it. If not, reject it. And likewise, as we go and emit back out into the VNet, we're also signing those requests with your VNet certificates. Now, with private endpoint, what's different is how do you actually bring connectivity for that now onto an on-prem, either an on-prem app server or to a laptop. Your laptop might not know how to go and do that signature verification of the VNet service endpoints. So with private endpoint, what we're doing is we're also basically redefining how we surface that DNS entry for Azure Cosmos DB. There's no public DNS anymore, and there's no way to actually resolve. It's also not surfaced through a public IP. So with private endpoint, what we're doing is we're publishing an internal, visible only within the VNet, a set of DNS entries, and those map to a set of private IP addresses for which we expose that database account. Does that make sense? Cool. I'm going to go and round robin the microphones.
Great talk, thank you. Question from me is, do you have any graph-specific features on the roadmap that we did?
Yes,
yeah,
graph-specific features on the roadmap. Yes, we're actually doing, on the short-term horizon, 2 major updates. One is if you're a Gremlin user, there's actually 2 ways for a client to connect into the database, right? One is you can pass a raw Gremlin string from the client to the server for the server to do processing. Gremlin clients are also pretty smart. They can do things like they can compile a Gremlin query into Gremlin bytecode, which can then also run against the server. One of the first things that we're working on is enabling that bytecode support so that you can get even faster and smarter optimizations between the client and the server on how they interact. The other thing that we're working on is basically the way Cosmos DB works is we have a backend and a front end. And where the Gremlin interop server lives along with our other interop APIs is on that front-end server. Now, what we can do with that is if we harden that to be resource governed for compute-intensive workloads, so if you're doing Gremlin queries that have much longer traversals or just a lot more long-running, where you're traversing many, many different vertices and edges, historically, that's where you'll find that there's a bit of friction in running those type of Gremlin queries. Basically, if I break out Gremlin into a set of transactional queries and a set of analytical queries, we work really well on the transactional queries side, right? And what the hardening the compute on our front end where we host that Gremlin query engine will allow us to go and over time extend over to computationally expensive Gremlin queries as well as long-running Gremlin queries. That's kind of the North Star on where we're headed with that.
Thanks again for the talk. It was awesome, great updates. Question regarding the transactional batch operations. Does that support the use case of having 2 different document types and updating them as part of that batch? So if you're in the same container, if you're like the type example that you had, can you do those now as a batch as long as they share the partition key?
Yes. So the main scoping for a transaction is it must be documents or items within the same partition key. But within a partition key, you can do anything you want. So if you're mixing heterogeneous different entities within the same partition key, then you're all good for doing ACID transactions over that.
Sweet, thank you.
Any thoughts on, do you guys have plans to support the GQL kind of standardized graph language thing that's going on out in the graph community?
We are evaluating both GQL as well as other graph query languages over time. A lot of it comes down to where we see market adoption. We do see a big center of gravity today at Gremlin, since that has been around quite a while and been sponsored by the Apache Foundation as part of the Tinkerpot project. But as additional different Gremlin query languages pop up, we are evaluating whether we want to go and add support for that as well. But no current ETAs for GQL yet.
Thank you for the talk. It's been really good. Slightly unrelated, but in a second provisioning of Cosmos DB, you can't configure location and configuration at the same time. That would be helpful for our CI/CD capabilities. So is there a plan to maybe support that in the future, or is that?
Oh yes, we're over time improving the robustness of the the ARM interface. Basically, both the PowerShell commandlets and the Azure CLI both are just talking to ARM in the back end. Some of the recent things that we've done, there's actually like even more low-hanging fruit in terms of reducing friction. You've noticed like one of the things that we had violated before on ARM is if you deploy the same template for a creation versus an update, this is, I think, the things that you're seeing with things like RUs, like creating a container with RUs and then updating the RUs used to not be able to do things like a put command on the ARM resource. We just revved our API version on ARM. If you use our new API version, that way you can actually use the same template for both creates and updates, and that way your CI/CD pipeline should be a lot more robust. But over time, we're also looking at additional functionality with that as well.
Thank you.
Yes.
Yeah, great talk. Got a question about the Autopilot feature.
Mm-hmm.
Will you be able to promote existing containers to use Autopilot?
We are looking at how to do that. Today, we don't have a migration path just yet. Admittedly, it's one of those things where we really wanted to bring this out to market quickly. And so we built the functionality first without a migration plan for the existing containers just yet. But over time, these are things that as we graduate this from preview to GA, that you can expect these quality of life improvements to happen.
Great, thanks.
Will these slides be available?
Will these slides be available? Yes, I'll post these online.
Okay. All right, thank you.
Thank you for the talk. I have a quick question related to, it's mostly related to the design of containers. When there are situations where you can actually host different types of data inside the same container, can you take advantage of the partition key to separate these data types between, instead of creating different containers? I mean, even with different schema. Is that something that is supported, is something that is recommended, or?
Not only is that supported, but we actually advocate that as a best practice.
Yeah, sure.
The containers themselves don't enforce a schema. And if you notice like little things that I showed, for example, the transactional batch operations, if you aren't mixing different entity types within the same container, it actually brings it outside of the transaction scope. So by combining these within the same container, you can go and do transactions across them. The other behavior we're trying to drive is why we're doing asking you to club different entity types within the same container is the container also acts as a natural boundary for queries. And what we're trying to avoid is how you model relationships within a container. We actually have a big data modeling talk, I believe, on Friday that goes a lot into the best practices of this. But the short TLDR of that is cross products are really expensive in a sharded system. You typically don't want to do that in any kind of transactional application. And if you club things together within the same query boundary in a heterogeneous way, from a Cosmos DB perspective, if you add a property, like imagine if I had a human record and a pet record, rather than go and join them on, let's say, a family of humans that have pets, I can go and just query off of a filter on a where clause where family ID equals and pull a heterogeneous set of both humans and pets in the same query without having to do a cross product. That allows us to do really, really cheap queries in a sharded system. And if you want to hear more about this, I highly recommend going to the data modeling talk on Friday.
Okay, thank you.
Yep. For the autopilot feature, what's the sort of, I guess, timing? And like, let's say you have a bursty workload and it scales up to maybe to your max. If that burst ends, how long can you reasonably expect that it's going to go down so you're not being charged for that max amount?
Got it. It's near instantaneous in terms of the actual scale up and scale down. And from a scale up, scale down perspective, you should also keep in mind from Cosmos DB that the elasticity of the system does depend on one additional factor, which is the scaling factor. So if I'm increasing, let's say, my throughput by 50% or by 100% or even by 1,000%, like a 10x growth, that's very different from doing, let's say, 1,000x, which would be 100,000% increase. These aren't equal in terms of how much we need to change the topology of the underlying cluster that we're running on for Cosmos DB. As long as you're within a reasonable scaling factor, generally speaking, like within 10x, all of the scaling operations will be instantaneous. Beyond 10x, you might actually have to wait a little bit for the cluster to reconfigure and grow a lot more. In terms of from a billing contract perspective, our billing today is still operating on a granularity of hourly. And so that's what you can expect from a cost savings perspective. So if you're looking at things like 1001 to 1002, don't expect too much savings from Autoscale. But where we will see a lot is from the hourly perspective. So example is you're building a line of business application that has business users that are hot from hours 9 to 5, but it's completely cold after that. This is where you're going to see a lot of drastic improvements.
Sure. I guess the question was more related to not how long does it take to do it, but what's the timing of when does it decide to scale back down?
Instantaneously. And that's why we wanted to build this as a first-class citizen. What we noticed is a lot of people started building these using a lot of the APIs that we have, both from the metrics perspective as well as our scale down and scale up programmatic APIs.
Right.
But the problem with metrics is there's always a delay. And so you get these dreaded 429s or these rate limit exceeded whenever, like, hey, you suddenly get a spike in traffic because it's a little slow to scale up. Right. And likewise, it's a bit slow to scale down. By baking this into the service itself, we're able to act at a very, very constant rate. It should be near instantaneous, near real time.
So you would only expect like the billing, like if you did spike up, even if it was just for a minute, maybe for that hour, you would pay the increase, but for the hour after that, you would be back down to your normal utilization?
Yes.
Okay.
So this is going to be super friendly, and within at least how we've defined things for now, we let you set a max threshold. We actually try to configure a cluster in such a manner that you can always go and hit that peak and basically hit both the peak as well as as a max value and 10% of that peak as a min value instantaneously.
It was the 400 to 4,000 was the entry level one, and then it went up from there, right?
Yes.
Okay, thank you.
I think you're.
Yeah, I mean, I can just talk to you if you're out of time, but I guess you were just talking about the, anything above a 10x, it wouldn't necessarily be instantaneous. So like in a Black Friday type situation where we would go to like 1000x for like doorbuster processing, I mean, is the intent that I could swap from like maybe the rest of the year I'm doing auto provision with a limit, and then for Black Friday maybe I want to have reserve capacity at my 100x or 1000x limit for that day? I mean, is the intent that I can switch back and forth between kind of the auto manage to like provision for that day and then back to auto?
The intent is to help with uncertainty. If you have workloads where you do have a high degree of certainty, or not certainty, but rather you can forecast, I actually find that using the manually provision is still strongly preferred because it can guarantee both the latency and throughput characteristics a lot better since we're actually pre-allocating and dedicating that hardware to you. From an autoscale perspective, the intent here is we do have a pretty large user base where honestly sometimes you have no idea, especially if it's a brand new workload. Like if you're doing a proof of concept and you haven't launched into production, getting an idea of what your production numbers will look like a lot of times is like, here's what the business would like to see, but we don't really know if that's actually going to be the case. Maybe when you go and launch something into production, it'll go gangbusters and it'll far exceed that. And likewise, sometimes maybe the business is a little overly optimistic in terms of what they're shooting for. And so when you have that high degree of uncertainty, that's where the Autopilot is really designed to be. It might not give you the same kind of predictability as a manual provisioned, but it does allow you to go, well, in the absence of, if you're just doing like a swag on, hey, how much traffic I'll have, it'll allow you to go and try to adapt the system dynamically to that workload. Cool. I know we've run quite a bit over in time. I'm going to just hang out outside if you want to come and chat more privately. Thank you so much, everyone, for coming to the talk.